Hello everybody. Now we shall discuss about Owen's bridge. Let E is the AC voltage given to this bridge. Let this is R1. R1 is the resistance of this resistor. L1 is the inductance of this inductor. R2, C2. This is R3, C4. Let E1 is the voltage across this branch. This is what E1. E3 is the voltage across this branch. E2 is the voltage across this branch. Let E4 is the voltage across this branch. Let I1 is the current flowing through this. I3 is the current flowing through this, I2 is the current flowing through this, I4 is the current flowing through this branch. Okay. The bridge is said to be balanced when no current is flowing through this detector. Under balanced conditions, under balanced conditions, Z1 Z4 is equal to Z2 Z3. What is Z1? Z1 is R1 plus J omega L1. What is Z4? Z4 is 1 by J omega C4 is equal to what is Z2? Z2 is R2 plus 1 by J omega C2. What is Z3 is R3. Now R1 plus J omega L1 by J omega C4 is equal to R2 R3 J omega C2 R2 R3 plus R3 by J omega C2. Okay, both will get cancelled. Okay, then you are going to get R1 C2 plus J omega L1 C2, which is equal to J omega C2 R2 R3 C4 plus R3 C4. Equate both real and imaginary parts separately. Then we get R1 C2 is equal to R3 C4. That is R1 is equal to R3 into C4 by C2. This is R1. By comparing imaginary parts, L1 C2 is equal to C2 R2 R3 C4. Okay, then L1 is equal to R2 R3 C4. Okay, right. Now in this expression, R3 C4 C2 terms are present. In this expression, R2 R3 C4 terms are present. Okay, now here in both expressions, R3 C4 are common. These two terms are common for both expressions. Okay, so one should not vary R3 and C4, as these two are common to both equations, balance equations. So it's better to vary C2 and R2. If I choose C2 and R2 as variables, then I can make these two equations independent of each other. Okay, so if we choose R2 C2 as variable elements, then the two balance equations independent, then the two balance equations are independent. Independent of each other. Okay, so you choose R2 and C2 so that these two equations are independent of each other. Okay, choose R2 and C2. So these two are variables. Okay, here you can write L1 is unknown inductance, R1 is unknown resistance, R2 is variable non-inductive resistance, whereas C2 is variable standard capacitor, R3 is fixed non-inductive resistance, whereas C2 is fixed standard capacitor. Okay, now let us find Q factor. What will be Q factor? You know, L1 is equal to R2 R3 C4 and R1 is equal to R3 C4 by C2. What will be Q factor? Q factor Q is equal to omega L1 by R1, then you are going to get omega R2 R3 C4 by R3 C4 by C2, then you are going to get omega R2 C2. That is, Q is equal to omega R2 C2. Okay, from this expression, for high Q coils, for the measurement of high Q coils, C2 will be more C2 is required. Okay, more C2 is required. Okay, large value of C2 is required for the measurement of high Q coils. Okay, so this is not suitable for the measurement of high Q coils. So this bridge is not suitable for the measurement of high Q coils. Inductor which is having high Q factor cannot be measured using this bridge. Okay, so this bridge is not suitable for the measurement of high Q coils, as we require large value of C2 in order to get high Q factor. And the variable capacitor is expensive. Okay, anyhow C2 is variable capacitor is very much expensive. Coming to this R2, the value of R2 will be, the required value of R2 will be more in order to get high Q coils, in order to measure high Q coils. Okay, so this bridge is not suitable for the measurement of high Q coils. Okay, anyhow this is variable capacitor. Variable capacitor is very much expensive. It is expensive. And large value of C2 is required for measuring high Q coils. Okay, C2 is more means Q will be more. So this bridge is not suitable for the measurement of high Q coils. Okay, this bridge is suitable for the measurement of medium Q coils. This bridge is suitable for the measurement of medium Q coils, that is 1 less than Q less than 10. Now coming to the advantage, if we choose R2, C2 as variable elements or variables, then the two balance equations are independent. Okay, here in these two expressions L1 and R1, no frequency term is present. Okay, so the two balance equations are independent of frequency. This bridge can be used over a wide range of measurement of inductances. Now coming to the disadvantage. This bridge requires variable capacitor. capacitor, which is an expensive component. And having low degree of accuracy. Low degree of accuracy. Okay, fixed capacitor is having high degree of accuracy when compared to variable capacitor. Okay, so variable capacitor is having low degree of accuracy. This will be having low degree of accuracy. This bridge is not suitable for the measurement of high Q coils. This bridge is not suitable for the measurement of high Q coils. As large value of C2 is required for measurement of high Q coils, this bridge is not suitable for the measurement of high Q coils, that is Q greater than 10. Now let us draw the phasor diagram. Okay, now let me take current as reference vector, I1 as reference vector. So this is I1, phasor I1. I1 is equal to I3 under balanced conditions. Current flowing to this is equal to current flowing to this. Current flowing to this is equal to current flowing to this. So I1 is equal to I3 and I2 is equal to I4. Okay, now let us take this branch. How can I draw the voltage across R1? Voltage across R1 is in phase with I1. Okay, so yeah, this is voltage across R1, I1 R1. How can I draw voltage across L1? Voltage across L1 leads current by an angle 90 degrees. So this will be I1 omega L1. Voltage across inductor leads current by an angle 90 degrees. Fair sum of voltage across this and voltage across this gives E1. So fair sum of these two is E1. Fair sum of these two is E1. Okay, this is what E1. E1 is equal to E2. Okay, voltage across this is equal to voltage across this. Under balanced conditions, E1 is equal to E2 and E2 is equal to E3. Okay, now let me draw voltage across this R3. You know phasor I3. How can I draw E3? Voltage across R3. Voltage across R3 is in phase with I3. So this will be E3. E3 which is equal to I3 R3, which is equal to E4, which is equal to I4 by omega C4, voltage across capacitor. E3 is equal to E4, right? Okay. Now, how can I draw this I4 or I2? I2 is the current which is flowing through this C4. I2 and C4 are equal. Sorry, I2 and I4 are equal. I2 is equal to I4. You know, current to the capacitor leads voltage by an angle 90 degrees. Current to the capacitor leads voltage across the capacitor by an angle 90 degrees. So if this is the voltage across the capacitor, that is E4 that is I4 by omega C4, then how can I draw I2 or I4? Leads voltage by an angle 90 degrees. So this will be I2. I2 is equal to I4. I2 is equal to I4. Now how can I draw voltage across this R2? Voltage across this R2 is in phase with I2. So okay, now this will be what? I2 R2. Now how can I draw voltage across C2? Voltage across C2 lags current through C2. So you can draw like this, lags I2. So this will be what? This will be voltage across C2, that is I2 by omega C2. Okay. I4 leads voltage across capacitor by an angle 90 degrees. Okay. Now fair sum of, okay, see here, fair sum of voltage across this and voltage across this gives what? E2. Okay, so fair sum of this and this gives E2. Okay, this is okay. Fair sum of this and this is equal to E2. Fair sum of voltage across R2 and voltage across C2 is E2. Okay, fine. Now E is the fair sum of E1 and E3 or fair sum of E2 and E4. So fair sum of these two is E. Okay, this will be what? This will be E. Fair sum of E1 and E3 or E2 and E4. Okay. Thank you.